guys, this is section 2.1. It's solving one-step equations. So I just want to put this out there. There are a decent amount of definitions. It's really just what's on the page right now, but I need you guys to take notes. I need you guys to write down any questions that you might have. Please be detailed in your notes so you don't have to come back to this video again. Now, it will always be available to you, but it's better to just do it the first time and not have to retrace your steps. So we will be going over this in class, but I want you guys to have a basic understanding before we do go over it in class. All right, so what we're going to do today is talk about equivalent equations. Now, these are equations that have the same solutions. So there are infinitely many equivalent equations, okay? Now, in order to solve these equations, we want to use the properties of equality. So we have four properties of equality written below: addition property, subtraction, multiplication, and division. Now, I'm going to give you an example of each to show you when you need to use them. I'm going to color code them. So the first one I'm going to do is in red, and that links up to the addition property of equality. All right, so let's get started. So our first equation is going to be, why does this always happen to me? Our first, let's see, nope. Sorry guys, bear with me. This is a new system. Okay, so what we're going to do is we have x minus 3 x minus 3 equals 2. Now, we have a variable and a number on the left, and we have a number on the right-hand side. Now, the goal of this situation is to get this x to be alone. We want to get this x alone, and then we'll get our answer. So we need to actually get rid of this subtraction sign and this 3. So what we need to do is use the inverse operation of subtraction, because that's the operation that's in our problem, okay? So the inverse operation of subtraction is addition. So we're going to add 3 to both sides, because whatever you do to one side, you have to do to the other side, because you don't want to change the value of the equations, okay? So when we add 3 to both sides, this left-hand side becomes x, and then we have 3 minus 3, or negative 3 plus 3. Now, when you use the inverse operation, it's going to go to 0. So you get x plus 0 equals, and then we're left with 2 plus 3, which we all know is 5. So I can rewrite this as x equals 5, okay? Now it's going to be really important that we check our answer. So I'm going to pull it back up here. I'm going to substitute this 5 in for x, just to make sure. So I'm left with 5 minus 3 equals 2. 5 minus 3 does in fact give me 2, so I'm good. Now you see, guys, we use the addition property of equality because addition was the inverse operation of subtraction, which was in our original problem. Okay? So now we're going to look below, and we're going to, I'm going to try to match it up perfectly, and we are going to, work on the subtraction property of equality. So the problem I'm going to use is as follows: x plus 3 equals 2. Okay? So again, very similar situation. We have 2 terms on the left-hand side, 1 term on the right-hand side, and we really want to get this x to the alone. So we need to move this 3. So we have a plus 3, which means we need the inverse operation, which is subtraction. So we're going to subtract 3 from both sides. Okay? Now when we subtract 3 from both sides, these cancel out because I get 0. 3 minus 3 is 0. So I'm left with x equals, and now over here I have 2 minus 3. 2 take away 3 leaves me in the negatives, and I have negative 1. So if I want to check my answer, what I'm going to do is plug this negative 1 back in for x. So I'm left with negative 1 plus 3 equals 2. And we want to make sure that I got the right answer. So I have negative 1 plus 3. That means I owe you $1. I pay you back 3, and you're up $2. So I am, in fact, correct. All right? Those are pretty simple problems, but all we're going to be looking at today is one-step equations. So you're halfway there. So next thing we're going to look at is the multiplication property of equality. Okay? So the equation we're going to be using is as follows. I'm going to do it over here. X over 3 equals 2. Now, this looks a little bit different because I have two terms, but they're in a fraction. So we all know that a fraction is division. So if I want to get this 3 away from this x to isolate it, I need to multiply on both sides. That's supposed to be like a dot. I need to multiply 3 on both sides. Now, the reason for that is because 3 divided by 3 gives me 1, which is exactly what I want. So I'm left with 1x, which is the same thing as x, equals 2 times 3, which is 6. Okay? Again, we just want to check, so I'm going to swing this back up here, plug in 6 for x. So I have x over 3 equals 2. 6 divided by 3 is in fact 2. Okay? Lastly, we have the division property of equality. Let's pick out my green right here. And the equation I'm going to be using is 5x equals 20. Okay? So when we have two terms written next to each other like this, it is a multiplication problem. 5 times x, okay? 5 multiplied by x. So we want to get this 5 away from the x because we need to isolate the x. So we need to use the inverse operation of multiplication, which is division. Okay? Divide 5 on both sides. Now when we do this 5 and this 5 cancel out because we have 5 divided by 5, which is 1, which is what we want. So we have 1x equals 20 divided by 5, which is 4. We want to plug back in, so I get 5 times 4 equals 20, and we all know that 5 times 4 is 20. So we are good, okay? So what we need to do is look at the problem that we have, figure out what is going on in the problem, and then figure out what is the inverse operation to move that term to the other side, okay? So I have one more problem for you, one more definition. So if you need this, pause it right now because I'm going to delete. So I'm going to take these away and I'm going to, where is it? I'm going to add this definition in, okay? So what we need to do right now is talk about quickly sorry guys. Okay. This is very confusing. Alright, we need to talk about what a reciprocal is. So a reciprocal is a fraction that's just flipped around. So an example of a reciprocal is this. So we might have 3 over 8 as a fraction. Let's just say 3 over 6 because it looks like a 6. 3 over 6 is a fraction. The reciprocal of this is just the numbers flipped around, 6 over 3. Now the reason that we need to use reciprocals when we're solving for one-step equations is because when we multiply two reciprocals to each other, we're going to do it right now and see what happens. So whenever we multiply two fractions together, we always just multiply across, okay? Numerator and denominator. So our numerator becomes 3 times 6, which gives us 18. And our denominator is 6 times 3, which gives us 18. 18 divided by 18 is 1. So this is like this golden number. We need, in order to get our variables alone, we need to get a 1 as the coefficient instead of the fraction. I'll give you an example of this right now. Okay, let's change our color. And then we will be good to go. So, our problem is going to be 4 over 5x equals 8. Okay? You see how our coefficient in front of the x is a fraction? We don't want that. We need it to be a 1, meaning that what we need to do is multiply by multiply by the reciprocal on both sides. 5/4. So we just talked about up here in the green that when you multiply two reciprocals by each other, you automatically get a 1. So that's what's going on the left-hand side. So I get an x on the left. That's what I have left over. So I can also write this 8 as 8/1 and multiply across. So I get 8 times 5, which is 40. Over 1 times 4, which is 4. 40 divided by 4 gives me 10. Okay, let's check. Okay, let's do a little check. So I'm going to plug in my 10 where my x was. So I have 4/5 times 10 equals 8. So again, I can write this 10 as 10/1. I have 4 times 10, which is 40, over 5 times 1, which is 5, equals 8. 40 divided by 5 is in fact 8. So I get that 8 equals 8, and I'm good. Okay, so again, please go back to any parts in this that you're not sure about. Please write down any questions that you might have. I'll be happy to answer them in class tomorrow. Remember, I'm checking homework.